Okay, in this lesson I'm going to do a quick recap on trig graphs and just investigating some of the key details about them: period, amplitude, the horizontal midway line, the range. These are important things to be able to discuss. So if I just throw up a trig graph here, this is the function sine of x. The parent function for all sine graphs looks like this. Okay. Couple of things to note. Notice where its horizontal midway line is. Halfway up there's a horizontal line. In this case it's the x-axis. The equation of the x-axis is y equals 0 because every point on the x-axis has a y coordinate equal to 0. So the horizontal midway line has a equation y equals 0. Let me just write that down here on my flip chart. So the horizontal midway line for the sine function is the line y equals 0. If I want to look at the amplitude is the height the function reaches above that midway line. So there's my highest point, and you can see here that's 1. Okay, above the midway line, that's 1. The total from bottom to top, this is 2 units tall. Half of that is just 1. Okay, or it's the height of the peak above the horizontal midway line. So the amplitude for the sine function is just 1. Okay. The period for the sine function, how often does it repeat itself? Well, you might remember this. Hopefully you do remember this from our work on periodic graphs and trigonometric functions. There's for one complete period, starting here where x is 0, finishes up here, just above here. In fact, that's 2 pi, 6.28 approximately, but 2 pi. The sine function has a period of 2 pi. 2 pi radians. Every 2 pi radians, it repeats itself. Or 360 degrees. 200. So if you take the sine of 10 degrees, that'll be the same as the sine of 10 plus 360 degrees, which will be the same as 10, the sine of 10 plus 360 plus 360 degrees. It repeats itself every 360 degrees. And then the range is just a set of outputs. So this is an infinitely many outputs. My set of y values here are my outputs, going from a lowest one up to -1, which is included, up to a highest of +1, which is included. So my range is from -1 to 1. All numbers between those two. -1 and 1 are both included, so we give those a square bracket. This is interval notation. If you're unsure about that, make sure you look up interval notation. Again, something we've addressed before. And what I want to go through, and you will have in your maths class, you will have addressed these things before, so I'm going to move through them quite quickly. I want to see what different coefficients do if I stick some number in front of the sine function. So for example, 3 sine of x, what happens there? Or if I multiply the x in the argument by a coefficient, what's going to happen there? Or add-ends, what happens when I add on a number outside the function or a number inside in the argument here? What is going to happen? So the first thing I'm going to examine is, I suppose, just this number here at the front. What happens as I change this value? So I've programmed this function to be, let me just see if I can get this a bit wider, to be a sine of b times x plus c quantity plus d. Okay, that's what I'm looking at. So a times sine of b times quantity x plus c, and then plus d on the outside. So I want to see what happens as I change a here. And I've put in some sliders here in GeoGebra that allowed me to change these things. So notice here, here's the coefficient. As I change a, you'll see that coefficient there changing. And so go back to my parent function, which is just when a is 1. Okay, there's my parent function. And you'll see as I move further away from the number 0, that will stretch the function. Stretches it away from the x-axis. As I move back closer to the number 0, that squishes it in towards the x-axis. And actually until I get to 0, well, we have a straight line because 0 times anything's just 0. And then when I make it negative, we kind of flip the function across the x-axis, and as it gets further away from 0, then it's stretching out. Okay, so if I just go up here to the limit here, notice when a is equal to 5, what's happening here? Well, my horizontal midway line does not get affected by this. The horizontal midway line for all of these things is unchanged. The period is not changing either. Notice one complete period is still 2 pi units along, so that's not changing. What is changing is the amplitude, which is the height it reaches above the midway line, and the range, which is the lowest to the highest point. Notice when a is 5, the range goes from -5 to +5, which is a distance of 10 units. The amplitude will be half that, 5 units. When a is 4, the range goes from -4 to +4, distance of 8 units. So the amplitude will be half of 8, 4 units above the horizontal midway line. So whatever value a is here is giving me the amplitude of the function. Notice, by the way, when I go down to my negatives, if I go to -5, my range is still from -5 to 5. My amplitude is still 5 units. So the amplitude is always the absolute value of whatever that coefficient is that's in front of the sine function. And I can write that down, and you need to kind of remember these details. The amplitude will always be the absolute value of whatever that coefficient is in front of a. Okay. The horizontal midway line is not changed by that coefficient. The period is not changed. The range, though, goes from the negative of the absolute value of a up to the positive. I'm going to leave a gap here because there's other things that can affect the range. But for the moment, multiplying by a will have that effect on the range, going from negative, the absolute value of a, to positive, the absolute value of a. So if when a was 5, the range goes from -5 to 5. And the next thing I want to look at is, I'm actually going to go over here and not one of the coefficients, but this addend on here. Notice it's outside the argument. It's not part of the function. It's kind of outside of the sine part. It's a second term, if you like. So we have sine a sine b of x plus c is my first term, and then d is my second term. What happens as I change that value for d? Okay, what happens as I change that value for d? Well, you'll see as I change that value for d, there's my parent function back there. As I change this value for d, as I increase it, my sine function goes up. As I decrease it, my sine function goes down. And I want you to look at the equation of the midway line, which I've put in here in black here. Y is equal to 1.4 at the moment. Y is equal to 2.1 here. Notice that's just the value of d here. Sine of x plus 2.1, which is outside a second term in there. So what that's doing is it's just shifting the graph up. If it's positive, it's shifting the graph down if it's negative. If it's 0, the graph has a horizontal midway line at y equals 0. Okay, and again, if we kind of throw those things in together, look at a stretch, say, of 5, and then shift this up, say, 2 units. And the horizontal midway line, y equals 2, which is the same value as this value of d, 2. The other thing to note is moving it up has moved the range. It's increased the bottom value of the range by 2, and it's increased the top value of the range by 2. It actually hasn't affected the amplitude at all. The amplitude is unaffected by this. It's still the same. It's still 5 units above the horizontal midway line. So what is affected by changing this number out here, which is not part of the sine term, it's just outside. What changes is the range on the horizontal midway line. The amplitude's unchanged. Notice the period is unchanged as well. And we can kind of summarize that by saying the horizontal midway line will always be y equals whatever d is out here. And the range, we just increase by whatever d is. If d is positive, that moves it up. If d is negative, that moves it down. Okay, so there there's my range, my horizontal midway line, and my amplitude. I just want to talk about the period of the function, and again reset everything back to the way it was at the start. My d is 0, a is 1, and I want to look at the coefficient inside the argument, this 1 here before the x, which is my value for b. If I change that, I just see how that affects the period. First of all, as I increase that, and I'm hoping you can see there, the period is decreasing. If I increase it out to say 5, now this period is now from here out to here. Okay. As it gets closer to 0, it's getting more stretched out, more and more stretched out, more and more stretched out, more and more stretched out, until at some stage it flattens, and then it goes negative, and it's actually flipped across the y-axis there. And as we get further away from 0, it starts to squish in again. So how can we summarize that? Well, let me just let, there's my b equals 1, my period is 2 pi. If I increase that to say 2, my period is pi. Actually, we've divided the period in half. We've divided in 2 by increasing that to 2. If I moved it to 3, that would be the period divided by 3. Okay, and in fact, the period is always going to be 2 pi divided by whatever this number is here. So the period is always going to be 2 pi divided by whatever that number in there b is. And in fact, it's the absolute value of whatever that number is. Okay, so we can figure out these important quantities from our trigonometric graphs. Just want to mention very quickly what the c does in here. It doesn't really affect any of these 4 quantities. What happens with c, let me just reset everything. What happens with c, there's my sine function. As I move c around, which is going to be the number that's going to be added in here, 2x inside the argument, it moves the function. As it gets bigger, you can see it moving there to the left. As it gets smaller, moving off to the right. So that moves the function left and right. Okay, if we add to x, we go left. Subtract from x, we go right. Okay, but it doesn't actually affect any of these kind of big 4 things. The range, the midway line, amplitude, period. And you've got to be able to look at, you know, pretty much any graph or any function without being given the graph and figure out these things. What's the period? What's the range? And it won't just be one, you know, they'll change different things. They'll change A, they'll change D, so it moves up and down. They'll change B to get the period to change. And on our course, not so much, but well worth knowing, they'll change that value of C, which will move the whole thing left and right as well. Okay, so they're all at motion in there. Okay, a little bit of artwork there for you. That's just the sine function moving around, changing the different coefficients. So, you know, well worth remembering this. Learn these by heart. I should be able to tell you any function. For example, if I said the function 3 plus 4 times sine of 5x plus 2, you know, I want to figure out everything about that. Well, the first thing, the period is going to be 2 pi over 5. The absolute value of 5 is 5. The second thing, the amplitude is going to be the absolute value of 4. The horizontal midway line is going to be y equals this term here, 3. Notice I've just stuck the 3 out the front here instead of as a second term, put it in the first term. And then finally, the range is going to be, well, it's going to go from negative 4 plus, so negative 4 plus 3 up to positive 4 plus 3. So from negative 1 up to 7. And you see that distance is 8 units long, and half of that is 4, which is the amplitude of the function. So we're in good shape. Okay, but I've got to be able to look at any function and be able to say what the period, amplitude, horizontal midway line, and range are. And so practice in there. Do use GeoGebra. Do, come up with different functions, see if you can figure out what the period, range, and amplitude, and horizontal midway line are. But you got to know those in order to be able to tackle the next part of our course.